Hey, look, I got a new background, and so does Miss Young.
Hey. So we are going to do this a little bit different. We're going to teach 3.5 through 3.7 together as like one thought. But there's like part A, part B, part C, and part D. And it just goes on and on. Anyway, we didn't want it to be like the longest video ever. And so in order to keep it from being the longest video ever, we are breaking it into 4 parts. Okay.
Let's do it. So we're going to talk about the components of an experiment today. Okay. So you want to talk us through, what am I looking at here, Miss Young?
So what we have here is a stacked bar graph where we begin to kind of look at the percent of all science paper authors broken into males and females. And we're like, is there a gender gap in STEM? Can I make the decision based off of this information alone? And the answer is no. We also should note at this point that this is an old study from 2005 where we weren't as sensitive. And so we do probably want to redo all of this where we collect data on people who don't identify by this binary male-female.
All right, so let's see if we can get a little more picture of what's going on here. So we gathered some more data because we thought we were curious. And again, we're still looking at old data. So we are now going to look at engineering papers and physics papers and math papers. Yes, like people write papers about math. And it doesn't get much better, does it?
In fact, I would venture to say that it gets worse. I mean, worse in my eyes. I guess if you wanted all of these STEM people to be male, you'd be like, better!
Yeah, I guess. Yeah, if you're team blue, but we would like to have more gender equity.
Yes.
And seeing that we're not seeing that. Okay, so
move forward to 2020 and consider all of the people that are in the data science workforce right now. Interestingly enough, my mother is actually a data scientist. She creates and maintains data banks for international banks. So she has been a data scientist from day one.
15%.
Yeah, she's in that 15%.
Well, my wife is working to change that. She's a computer science teacher. So
yeah.
Anyway, let's move on.
So what we're going to look at today is it possible to find the true cause of what's causing these gender gaps? Like, why is it that it's mostly males and very few females? And there is a lot of speculation that hovers around this topic.
Yeah. And there's a lot of opinions, but we want to try to find data that supports the facts. So there's a few essential knowledges we need to talk about. And I think we've talked about a lot of this before. The experimental units are the objects or the things that we are studying. Sometimes people get this confused a lot that they don't necessarily have to be people. We're talking about people again, but if we're gathering information about tree frogs in the Amazon, then our experimental units would be the tree frogs.
Yeah, okay? My sister-in-law studies strawberries.
So
like actually across the United States, she studies strawberries.
Okay, that would be experimental units. And it all depends on what you're studying, okay? Then we have the explanatory variable.
And the response variable, and I feel like we've hit that and hit that and hit that, so if you're still confused, just hit pause and read, and we're going to move on.
And then the confounding variable is the new piece here, and that's, a lot of people get confused about that. That's probably that's maybe not the best wording for it, but what is a confounding variable is what you might think something is playing a role, but you might be wrong. There might be some other factor that's causing. Okay.
I like that this definition includes false perception, because I think that's exactly what happens is sometimes we assume something is being caused by something else. We have a false perception of what's happening because there's some confounding reason that it's actually taking place. And we're always, as statisticians, we're always looking for what could be confounding the situation.
We don't really want to try to mix up. I mean, you watch one network, they'll tell you one reason, another network will tell you another reason something's happening. Trying to avoid all that. We want to get right down to what's actually going on.
Right.
All right, so we've already beat this one into the ground, but this, you can't say this enough. Just because there is some kind of we see a statistical relationship doesn't mean that A causes B. So we have a couple very good examples here. How much margarine you eat is not related to how likely it is you are to drown. And you see all of these stories and hear all these things. People mix this up and then they get into real trouble. There's not necessarily a
So he's paused because his internet's funky. So we'll just pause the video until he comes back. Oh, there he is.
Yeah, okay. I was fine.
For a second.
So let's go back to the data about the science papers and the gender.
Mm-hmm.
What might cause this? What do you think causes the difference?
I mean, like, there's a huge part of me that's like wearing my feminist britches. That's like, men cause this. Men don't want women in their jobs. Men want to hold the women down. But I think there are probably a lot of things that go into this.
I'm just going to click and not argue with you. So, one possible cause is hiring discrimination. Do people tend to hire males more than females? That's a possible reason. Okay. So we could say there might be discriminatory practices in hiring. Okay. Which would result in fewer women entering the field.
Right.
Okay. Can you prove that though? Miss Young, you got your female britches on.
I mean, right now, I just suspect it, but I have nothing besides my suspicion that leads me to believe that. Just my like snarky sense of self.
Yeah, and hey, honestly, you know what? I haven't hired many people in my life, but when I have, that's not a factor. I promise you, it's not a factor in my hiring decisions when I am on a hiring committee. Okay, but you can't prove it. I mean, you can suspect it. You can go up there on Facebook and shout it from the rooftop, but that ain't proof.
And people do.
Oh yes, they do, and that's why they're not statisticians. Okay. Statisticians would try to design an experiment and figure it out. So why can't we do it? Because there are many other reasons. Could you possibly think of another reason why there might be a difference? I can think of one, dealing as a math teacher and working in many schools. I see a lot of young boys being encouraged more to do science and engineering than young girls. And I imagine that might have an influence. Could you wrap your mind around that as a possible?
I believe that I think that males are sometimes pushed more towards the sciences early on in school. I don't really think in the last 10 plus years that happens as much in high school as it used to. But I will say it takes a long time to turn the tide, right? There's, especially like grandma and grandpa aren't telling, granddaughter, might not be telling granddaughter, like, I think you'd make a beautiful chemical engineer one day. Like, I don't know that that's happening, know?
And even if it's happening now and things are better in schools now, it's going to take 20 years for those people to enter the workforce.
Yeah.
So what we're seeing now in 2020 is a result of what happened when you and I started teaching. So, okay, so there might be another reason is all I'm trying to say.
And it's important to note that there might be another reason, because if there might be another reason, then you need to figure out how to remove that reason before you go into trying to design an experiment to think about your reason. Try to eliminate those confounding variables from your study or your experiment.
All right, so let's take a look at, so we have more about the confounding variable.
So this is what we just talked about. Couple of reasons, girls aren't as encouraged to pursue STEM subjects.
Right.
Therefore, there aren't as many pursuing. And I do honestly believe that there are less females pursuing engineering degrees as there are males. And I don't know if it's lack of confidence or being pushed or what it is, because I know for sure in my long years of teaching that the female brain is just as intelligent as the male brain. So
Would agree. So, all right. So again, more about the and this is the exact opposite of what we said, that if younger boys are being pushed, then they would result in STEM careers. Okay. So we had at least 3 theories now about what could be causing this. Okay, we don't know, and I mean we have suspicions, and Miss Young and I have experiences, but that's not stats. That's just gut feeling. And I'm going to go on Facebook and I'm going to go post this, and people are going to like it because they're going to like what they like, but that doesn't mean it's right. Okay.
Yeah,
so
this graph kind of makes you feel like icky on the inside because it makes you go to bad places before you have any proof to go to bad places.
Mm-hmm. So we got to figure out a test. We have all these things going around, and we want to try to figure a way to test it. And like Ms. Young said, how do we focus our test onto the one thing we suspect? Okay, so let's try to do that. Okay, and we talked about there's different ways of doing it. There's an observational study where we gather data without doing anything. We're not like, if an observational study, I'm not changing and
We're just watching.
Yeah, observation. We're just watching. Okay. So we gather data and see what they are, and that's it. Okay. And then that,
Back just a little bit, Mr. Bobby. So it's important to know that observational studies don't show you cause and effect. Okay. They do not show cause and effect. You can do an observational study, make decisions based on your observational study, but that piece is missing. Okay. And because that piece is missing, we might not want to always do observational studies. All right, now move on.
And sometimes we can't. That's all we can do, though, in some cases, because we cannot make people take certain medicines or whatever. All right, so move on. All right, so we have this data. Oh, our faces are over it.
Well, I'm recording, and our faces are not over it.
My faces are over it, and I can't see it. So, have we tried to influence the people or the participants? The things. Have we imposed any treatments on these people?
No, we literally just collected data and made a graph.
Are we tracking them for future? We're
just literally collected the data that existed and made graphs.
And so we cannot show a cause and effect between the 2 variables. All right. So, all right. Now the other case is if we did an observational study when we don't do anything. The opposite is an experimental study where we actually do something or treat the subjects, do something to them. We either give them something or withhold something to see if that, in fact, does change the variable.
And most people's brains, when they think experimental study, goes straight to like some medicine, like, oh, we're testing this medicine and it's an experiment. That's true, but there are so many experiments that exist on this world. In fact, like farmers do it all the time when they like change fertilizer to see if it helps.
That's the example I was thinking in my head.
I just snatched it.
Okay. Exactly. Okay. Give them a certain level of different levels of fertilizer and see what's the best amount. Okay. All right.
Now, what we want to do when we do this is we want to find a way to control possible confounding variables. Okay. So that's what I meant when we're trying to zero in. We want to control possible confounding variables.
So what do we think causes the differences in males and females in these subjects? And Young posed the hiring discrimination theory as theory number 1.
Yeah.
was your very first gut check theory. Now, she may be right, she may be wrong. I don't know, but
Be right. She may be wrong. Okay, sorry.
all right.
But
So
I
we
just don't think. Okay, I'm done.
that theory. We want to see if Miss Young's
Yeah.
theory is correct. Okay. So how do we do that? How can I design something that will just focus on hiring?
How about we do an experiment on hiring?
Or how about we just read what Yale has already done?
Smart. That is smart. Yeah.
Okay. So this has actually been done. There's some researchers from Yale who designed an experiment. We're going to talk about that, go over at least the overview of the theory. Okay. So they wanted to test gender bias in hiring. Okay. So how do they do this? I mean, we're not going to make you can read the study and go all into it if you want, but we're just going to do the summary here. So here's a short version, a simplified version of what they did. And like I said, you're welcome to go read the full paper. Okay. You want to talk about the experiment, or you want to give them
Sure. So basically what happens is in the beginning, and they are creating two resumes that are identical. And so we want to also note here that the applicant doesn't have a lot of experience, but has that high GPA, has that degree in biology, like looks good. We've got an applicant who looks good. And then they create a second applicant. So they create this second applicant, and if you look here, we've got a major in biology, same GPA, same background, same internship, and the only thing that you're going to see different here is the first name, John and Jennifer. Okay, so we've got a male applying for a job and a female applying for a job, and they look the same on paper, except for that first name only. Not only do they look the same, but even the names are safe and vanilla. Right? So you have to think about confounding from any direction. Like, is it a racial bias? Does it sound like, oh, I want to hire a white person, or I want to hire an African-American person? So even they were careful to make sure to get nice, bland, trustable names.
Not a Jose and Jennifer, or whatever.
Yeah.
Okay, so we got two very similar two people with similar resumes, but with only one difference, and that's the difference in gender. Okay. So, in those names, like Ms. Young said, they have been pre-tested for likability and recognize they're, just don't pick Karen, right?
No, nobody wants to hire Karen.
Nobody wants to hire a Karen right now. So anyway, all right. So they've got 127 Jennifers and Johns.
No, they've got 127 people reading the application.
Sorry, yeah, they had 127 people reading the applications or their resumes. Okay.
Yep.
All right. So we read them, and look what happened.
63 people picked John. 64 people picked Jennifer.
Curious. All right.
Curious.
So they gave the applicants a better hireability rating, and it looks like about the same to me.
Okay, so in this particular experiment, and we are going to wax philosophical about this experiment, not all in this video. It's important to note, so that we talk about our appropriate statistical language, that if we want to talk about the experimental units, in this case, Mr. Bobby, who are the people or subjects that are being assigned different treatments?
Well, they're the people, the science lab faculty that reviewed the resumes.
And then what is the variable that we are purposefully manipulating in this situation?
The name or the gender of the applicant.
And this is also called factor. A lot of times you're going to hear like, what's the factor? So in this case, the factor would be that first name.
Mm-hmm. Which I assume implies gender. So, or at least at the time.
Yeah. So the different levels of the explanatory variables are called treatments. So in this case, that is your Jennifer John. Yep.
Mhm.
And then the response variable is the measured experiment outcome, which we now are saying is that hireability rating and that salary estimate. So we're getting two numbers here. And we're going to stop because we're talking. So now's the time to pause and go do a little Khan Academy, and then we'll catch you on the next one.
All right. Bye, y'all.
Bye, guys.